right, so what we're doing now is we're starting our new unit. And this unit has lots of um, concepts in it, so make sure you keep up. And when you aren't understanding something, make sure you're asking. Okay, our goal today is I can state restrictions and simplify rational expressions. So first of all, let's talk about rational expressions. What are we talking about here? Well, let's recall that a rational number can be written in the form m over n, okay, so like a fraction, where m and n are integers, and we also know that our n cannot equal 0. Now, the reason it can't equal 0 is because we can't divide by 0. Now, the definition of a rational expression, very, very similar. Rational expressions can be written in the form p over q, where p and q are polynomials and q cannot equal 0. Okay, so very, very similar definitions. Now, here what I have in front of you now is 3 examples of rational expressions. The first one, x squared plus x plus 1 all over x plus 2. Okay, a polynomial over a polynomial. Now, no problem there. And the same with the next ones. Now, the problem happens behind here, as soon as I change, there we go, is I know that x cannot equal -2. Because if x does equal -2, my denominator will equal 0, and I can't have that. Okay, the same is true here. X can't equal 0. And lastly, y cannot equal -1. So what we say the values -2, 0, and -1 for the above examples would make the denominator equal to 0. We call these numbers restrictions on the variables as the expression is undefined at these values. Okay, so those are the restrictions. Okay, and every time we're working with one of these rational expressions, if we're not told what the restrictions are, we must find out what those restrictions are. So let's look at restrictions first of all. Example, state the restrictions for each rational expression. Okay, so let's look at the first one. Again, the only part that I'm interested in is the denominator, because it's the denominator that determines what the restriction is. So in this case, the only way that 3y would equal 0 is if y equals 0. So therefore, the restriction on this one is y cannot equal 0. Okay, then if we go over to this other side, no problem again. We can say a minus 4 equals 0. What will make that occur? That occurs if a equals 4. So we know our restriction is a cannot equal 4. Now those ones you could easily do without writing them to the side, but then what happens is we get something like this. Okay, again, not that it's any more difficult, it's just that when I'm looking at my denominator here, it's much more complicated in the sense that I'm going to need to factor. Okay, so remember we spent some time on factoring. So the first step I have to do is factor that denominator. That denominator, if I factor it, would be 2 numbers multiplied to give me 4. They subtract to give me 3. The largest one is positive. Okay, so we're looking at 4 and 1. The largest one is positive. And I quickly just check to see if that's correct or not. And let's see, I get that b squared. I'm getting a -1b, a positive 4b, which is a positive 3b, and finally I end up with a -4. So I factored it correctly. So now it's much easier to see what values I cannot have for b. Now b cannot equal -4 and positive 1. All right, so let's look at the 2 more here. Okay, the first one, again, I can solve it 2 different ways. It is a difference of squares. You maybe recognize the difference of squares here, or maybe you didn't. Either way, it'll work. So if I take and change that to x minus 3, x plus 3, I can then see that my x cannot equal plus or minus 3. Then let's take a look at the next one. The next one, Okay, it is an addition of squares, so I can't write the factors like that. However, I could take the denominator, set it equal to 0, and solve for x. So when I do that, I get x squared equals negative 9. X would equal plus or minus the square root of negative 9. Now you know that that's an issue because I cannot take the square root of a negative number. Okay, so what does that mean when we're talking about restrictions? Well, what it means when we're talking about restrictions is because this is not allowed, it means there x can be anything. So there are no restrictions. There are no restrictions. And if you look a little bit closer at that question here, if we look at this, how can I make that bottom equal 0? Well, the only way it could equal 0 is if this x squared equaled negative 9. And there's no way that I can take a square of positive numbers or negative numbers to get a negative number there. So that's why x can be anything. All right, moving on to the next part. So I told you that we're responsible for coming up with restrictions, and that is only a minor part of the questions. So here we're asked to simplify rational expressions. Now recall when you simplifying fractions, okay? So if you notice, I'm always going back to something that you do know. So if I have 30 over 35, and you know that that is not in lowest terms. Okay, it's not in lowest terms because I can find something that goes in the 30 and something that goes in the 35. And you know that in both cases, 5 goes into both of them. Okay, now I wrote it like that so you can see that when we simplify it, we're actually canceling out the 5s and we're left with 6/7. And now that's in lowest terms. So let's look at simplifying rational expressions because we're not going to have numbers in the sense of constants. We're going to have polynomials. So simplifying steps. So we're going to write down the steps first, then we're going to keep going back to our steps when we're solving. Okay, step number 1. And we're going to factor numerator and denominator. In this kind of section when dealing with rationals, if you're ever in doubt, make sure you factor. So factor numerator and denominator. Determine the restrictions, and remember the restrictions are just on the denominator. Divide out the greatest common factor. Okay, so when I look at the fraction one that I did here, the greatest common factor there was 5. State simplified expression with the restrictions. So we state the restrictions at the beginning and we state them at the very, very end. Okay, and if in doubt, relook at number 1 as far as steps go. Everything is factoring. Okay, so let's look at the first example. The first example here is 2x squared y cubed all over 8x. Okay, so step number 1, factor. Well, guess what? I can't factor it. It's already done. So let's take a look at our restrictions. Okay, our restrictions here, x cannot equal 0. Okay, so I'm just taking the denominator here and calculating that. Now, on the top here, I have a 2, and on the bottom, I have an 8. So 2 goes into itself once, 2 goes into 8 4 times. Then I'm looking at the next ones. On the top, I see that I have x squareds. On the bottom, I have 1x. So the x goes into itself once, x goes into x squared once, so that we have just an x. Okay, now some people just cross out just the power, and you can do that too. Just make sure, if you notice, once you start crossing stuff out, it starts to get a little bit messy for our brain, so just keep track of that. So what I'm left with, on the top I have an x, I have a y cubed, and on the bottom I have a 4. Okay, so that is simplified, and then I must restate my restrictions. So x cannot equal 0. So it's just that simple. So let's look at the next one. Okay, step number one, factor. Well, it looks like there's some brackets here, so someone had been doing sum. However, they didn't finish it because if you look here on the denominator, I have an x squared minus 2x, and in that bracket you can see we have a common factor of x. So I need to get that factor of x out. So let's go first of all and do 8 2x minus 1 stays the same over 4, we're taking out the x, we're left with an x minus 2. Okay, so we have that factored now, top and bottom. So what we want to do next, again, is we're going to state our restrictions. So we're interested in the denominator. The denominator is telling us our restrictions. So if I look at the first one, you can see that it's 4 times x. What will create a 0 there? Well, x cannot equal 0. And if I look at the bracket, I can see x cannot equal positive 2. Okay, so I've stated my restrictions. Now I can cancel out factors. All right, so first of all, 8 goes into, well, 4 goes into itself once, 4 goes into 8 twice. And then I look to see, is there anything else that I can cancel? Okay, now some of you are saying, well, I see a 2 here and I see a 2 here. Yes, however, I can't cancel them because if we look at, first of all, the 2 in the denominator, it's attached to another item in the denominator by subtracting. So if the operation is not multiplying, I cannot pull it away. I can't cancel out. Okay, so question number 1, for instance, it was 2 times x squared times y cubed all over 8 times x. So everything was being multiplied, so you can rip things apart. Here I can't. So the only thing I can do is what we just finished doing. So we're left with for our answer is 2 bracket 2x minus 1 all over x minus 2. And we leave our answers in factored form as well because in most cases we're going to use it for something else later on, definitely next year for sure. Okay, let's do 2 more examples here. And step number 1 is to factor. So let's take a look at this. All right. First of all, in my head, I'm going through my steps. Common factor first. In my numerator, I have a common factor of 5. I take it out, and I'm left with 20 divided by 5 is a 4x squared. 25 divided by 5 would be a negative 5. Okay, and in our denominator, I don't have a common factor. However, I have a difference of squares here. And you can see the difference of squares. This is the square root of this one is 4x squared. The square of this one is 5. So I have 2 brackets. They both have 4x squared and a 5 in them. One bracket has to be positive and one has to be negative. Okay, so both of them have been factored to the numerator and denominator. So now it's a matter of calculating my restrictions. Remember, the restrictions are based on the denominator. So I'm going to take a look at this first one, plus 5 equals 0. So 4x squared equals negative 5. X squared equals negative 5 quarters. Okay, you can see what our issue is here. X equal plus or minus square root of negative 5 quarters. So that one's not creating any restrictions at all for us. However, if we take the next one, you can see that we're going to have x equals plus or minus the square root of 5 quarters. Okay, so we know when we take the second one, the negative one, that we're going to get that. So that is our restriction. Okay, so we're going to write that down next. Okay, and so finally what we need to do is we need to cancel out any factors, and you can see that this bracket is identical to this bracket. So those are gone, and we're left with our final answer of 5 over 4x squared plus 5, and my restriction is x cannot equal plus or minus the square root of 5 quarters. Okay, now you don't need to put a bracket on the denominator. However, I just think that it looks better if it's done that way. Okay, next video for next question.